Hey there, curious thinkers. Welcome to the Why, a place for questions hiding inside ordinary moments. Have you ever stopped mid scroll, mid thought, just because the sky decided to show off? You know that feeling, right? The end of the day, air cools down, the sun dips below the horizon, which looks like a masterpiece painted by nature. But here's a question we almost never ask. Why are sunsets red? There's some fascinating science behind this daily spectacle. Our journey to understanding red sunsets starts with the sun itself. Now, the sun might look yellow or white to us, but it actually emits light of all colors, vibgyor. Together, these colors make up what we call the white light. But here's where the Earth's atmosphere comes into play like a cosmic disco ball. Our atmosphere is filled with tiny particles, mostly nitrogen and oxygen, along with dust, water vapor, and other small particles. When sunlight hits these tiny particles, the light gets scattered. This scattering isn't random. It's actually a phenomenon called Rayleigh scattering, named after a brilliant physicist. And here's the key. Blue and violet light waves are shorter and scatter much more easily by these small atmospheric particles, bouncing off in all directions, creating our beautiful blue skies during the day. So during the middle of the day, when the sun is high above, its light travels a relatively short distance through the atmosphere. The blue light gets scattered all over the place, making the sky appear blue from wherever you are. Most of the other colors like red and yellow mostly pass straight through, reaching our eyes directly from the sun. Show the sun much lower on the horizon. The path of light through the atmosphere should appear much longer and thicker. But now, imagine the sun beginning its descent. As the day draws to a close, the sun sinks lower and lower in the sky. This means its light has to travel through much more of the Earth's atmosphere to reach your eyes. It's like taking the scenic route home. And because that path is so much longer, even more of the blue and green light gets scattered away and filtered out. It's almost completely gone by the time the light is reaching your eye. What's left? That's right, the colors that are less likely to scatter, the ones with longer wavelengths, red and orange, are the champions that manage to push through that extra thick atmospheric gauntlet. They make it all the way to our eyes, painting the sky with those incredible warm hues. Isn't that incredible? Every sunset is a live demonstration of physics and optics. The amount of dust, pollution, and even water droplets in the air can affect how much light is scattered, which is why some sunsets are more dramatic than others. Volcanic eruptions, for example, can pump tiny particles high into the atmosphere, leading to exceptionally vibrant and prolonged red and orange sunsets around the world for weeks or even months. There's something comforting about knowing this happens every day. No matter how chaotic the world feels, light still bends, air still scatters, and the sun still says goodbye in color. Maybe that's why sunsets feel emotional. Let's explore this curious question next time. If you enjoy finding meaning inside simple questions, subscribe to Why for Curious Thinkers. Because the world is full of wonders,